Going to have 3 memory locations down here before the dot end. We've got some values in each one of them. Don't know what's in there. I want to write a program that will go through and arrange those things into increasing order, so that we get the smallest one into A and the largest one into C. Okay, now writing the code to do that in a high-level language is relatively straightforward. There are some things, of course, you have to look out for when you start swapping values around. You're probably aware of that. You'll see that we have some similar problems here, and they aren't solved in quite the same way. Okay, but one of the things that we have to do, of course, is determine, to take 2 values and see which one is the larger. So we really have 2 problems. We have to determine which of 2 numbers is the larger, and then how to swap them if they're out of order. Okay, so it's almost certain that it won't fit in here, so okay, a logical way to begin this is to compare A and B and get them in the right order. So we will load register 1 from A and load register 2 with B. Now, the logical way to find out which is the larger is to subtract one from the other and see whether or not the result is positive or negative. Okay, so in order to subtract, remember we have to get the negative of one of these things, which we do by taking a naught and then adding 1. Okay, so at this point, just as a comment, register 2 is minus B. Then we'll add that negative number onto it, and so now register 1 is A minus B. Now, I said we wanted to put these into increasing order, so I want the smaller one to be first. That says, well, I'm going to put in a branch instruction in here, followed by a swap routine. And here's where I'm going to branch to. What's my branch condition?
Must have been negative. Negative?
Doesn't matter. Once.
If it's negative,
That means B is bigger.
then B is bigger.
So they need to be swapped.
So I do not swap in that case, because I want ascending order.
Oh.
If If it's negative, A is smaller than B, and that's the way I want it. So if it's negative, I'll branch down here, I'll just call that label A is less than B. Now we can do the swap. When you do the swap in the high-level language, you generally have a temporary location. You copy one of them into the temporary, then copy the other one into that, and then the temporary into the remaining one. You can't do that here because this language does not have memory-to-memory transfers. I can't transfer from one memory location to another. I have to go through the registers. Now, here's one of those places where you can stop and think about things. Let's do this and then we'll look at it and see. Okay. I'll load them and then I'll store them in the other order. Store register 1 into B and store register 2 into A.
Then you've overwritten one of your values, now you have the same number, right?
It's what?
Now you have the same number in 1 and 2. You don't have, you didn't switch.
No, I don't.
You copied them, right?
Notice up here, this is something to look out for. I destroyed both A and B up here in this thing. I destroyed B because I took its negative. I destroyed A because I added this onto it.
Oh, yeah.
I can save myself a little work down here by making one rather simple change. If I do that add into register 2, then register 1 remains unchanged. That was my A value. So I don't have to do this because it's still there. Okay, but I do have to retrieve the B because I really messed it up here, and then again here. So I retrieve the B so that I can copy it into A, and the A value, which is still in register 1, hasn't been changed anywhere. I store that into the B memory location.
So that comment would be R2 equals A minus B?
Yeah, yeah, I changed that.
Could you use R3 to not B?
You could. Yeah. Yeah, we could go through and do the not, put it into register 3, and then add 1 into register 3, and leave B unchanged, and then all you would have down in here are your 2 store instructions. Beneficial? I don't know, maybe. Okay. Next step. Well, it's going to be very much the same. We're going to do the same kinds of things. But now we want to compare A and C. When that's done, we know that the smallest of the 3 numbers will be in A, but we don't know about the relative sizes of B and C. It takes the 3 comparisons. Now, if I have come to here, I still have A in register 1. The way I've modified this, A has not been changed. So I don't have to reload that, but now I need to get C. So I'll load register 2 from C. Now let's look at this idea here. We now want to take put the negative of C into register 3. And then we'll add that gives us A minus C. Register 3 is now A minus C.
So you're putting them in ascending order in the registers or in the memory?
Into the memory.
Okay.
I want to change it in the memory. Now, having written that little block of code, well, let's just trace something here and see what happens. Let's see. I suppose we have these values. Let's see what we end up with here. I did only registers 1 and 2 here, so let's see. We load A, so we got 0, 0, F, 3. And then we load B into register 2. Then we do a not here, which gives us F, F, B, B, and then we add 1, which gives us F, F, B, C. That gives us down to here. Now we'll add register 1 onto that. 0, 0, F, 3. 12 and 3 is 15. 15 and 11 is 26. That's 10 plus 16, 1, 0, 1. Okay, the result is not negative. That means I need to swap them. Well, yes. When I look at those values, notice that 4, 4 is certainly less than F3. And so trying to get that smallest number up there, I need to swap them. Okay, so I load register 2 again from B. So this goes back to 0, 0, 4, 4. Then I store register 1 into B. So now that becomes 0, 0, F3. And then I store register 2 into A. That gives me this one. Now I load register 2 with C. I didn't put a value in there for C. And I'm going to compare A and C. Well, I'm going to compare register 1 with C because of this. What am I actually comparing?
B.
B. If I take this branch, I'll be all right. If I don't, I'm not. I'm comparing the wrong one. Does everybody see that? It's one of those things where sometimes it's called a phase error, where when you go through the thing, sometimes when you work it, it does correctly, and sometimes it doesn't. If I start with A actually being less than B, everything goes smoothly. You think, yeah, we got it made. It's doing it correctly. Get them out of order, and suddenly it's not. You have to watch for things like that. In order to prevent that, you actually here need to reload that A, just in case, so that you're comparing the correct thing. Now then, we'll because we're doing it in basically the same way. If that's negative, it means that A is less than C. And so I will branch down. Otherwise, I'll do the swap. The swap, again, now this time I did not destroy registers 1 and 2, so I can just store them. Let's see, we'll store register 1 into C and register 2 into A. Now we have our A less than C. When we get to that point, we know we have the smallest number in A. And then we just need to do the same routine again, comparing B and C. So we will and then a not. Okay, we'll subtract the C. One. Now, here, because I have taken B minus C, if this is negative, it means B is less than C. Otherwise, now we want to swap them, so we'll just store C, which is in register 2, into B, and register 1 into C. Okay. Basically, if that's all we want to do, we're done.
That should be a negative case, not a zero, right?
Oh,
Down here
yes.
is a negative.
Why did I
Zero,
say
that was
Z?
zero.
Yes, it's branch negative. What if they happen to be equal?
More codes.
If they're equal, let's not do the swap. You don't need to. I mean, if they're the same, it doesn't matter if you swap them. You've still got them in as close to the order as you can get. So, in general, it's a just slightly more efficient. Oh, I had the Z down there too. NZ. If the result is 0, that means they're equal and it doesn't do you any good to swap them. So let's not waste the cycles on it. Okay. If you think about that for a while, you see pretty quickly that trying to sort a list of numbers is probably going to be just a little bit tricky. The best way to handle it in the long run, remember we actually put up here a couple of different versions of the bubble sort. One of the best ones is this one. Done writing this in C. We say done is true, and then we'll say while not done, equals false. And then for working descending order, so we'll say here, if it's greater than AI plus 1, then we'll swap them. T equals AI equals AI plus 1, AI plus 1 equals T, and now I'll change done back to false. And that's the end of my while loop. This one is relatively easy to implement in this assembly language. Because you see, I can load the address of one of the memory locations into a register, and then by using that base and offset thing, I can get a hold of this one and the next one very easily. And as I loop through and change this base address, I don't have to change the offsets. The offsets will be constant. I can work through it. And we can do this scheme. We find the negative by taking naught on one of them. Well, let's see. We've got enough time here. I can write a loop that will do this part of it.
What's that last line before done equals false?
Oh, AI plus 1 equals T, my temporary location. Typical swap routine there. Okay, look, as we get into this kind of thing, we'll begin the for loop by looking at A0, the first element of the array. So I load the address of A into register 0. Now this is where my loop actually begins, and I'm going to dodge some of it because we've only got 5 minutes here, but I want to get to the essence of the thing. I want to use this load relative instruction to get the contents of that memory location into one of the registers so I can work with it. You remember, you have a destination register. This is a base register. It's going to add this number onto the contents of this register and put that in the memory address register so that it fetches that location in. That's register 1 is now AI. At this point, I is equal to 0, but we won't fuss with that. Then I'll load register 2 using an offset of 1. So the 0 gets me one memory location, AI. Adding 1 gives me the next one. So I'm looking at 2 adjacent memory locations. Now I can do the trick we just did here to compare those. Let's see. Greater than, I wrote it so that if it's greater, well, we will take that not, and then we'll add a 1, and then we'll add register 3 to register 1. Now let's see if I got this in the right sequence here. what I have here is that register 3 is AI minus AI plus 1. Register 2 here gives me 2AI plus 1. Yeah, if the result is negative or 0, I skip around all of this stuff. Otherwise, I do this swap business. Well, because I haven't changed anything there, I can simply store, let's see, store relative using a 0 here, puts it into this location. If I store relative register 1, that takes what was in here, what was in here, and puts it in this location. Okay, now the thing we haven't really talked about here is to handle the done variable. But, and I also don't have any kind of a loop counter, so we adjust our loop counter and branch back to this location loop. Okay, this one is a whole lot easier than doing the nested for loops, where you compare the first one with everything to the end, and then the second one with everything to the end, and so on. Compare each one to the next one, and it's easier to work with in the assembly language. That's the idea. Okay. Anyway, any questions there? Yeah.
I want to go through that STR, register 2, register 0, number 0.
Okay, remember, the way the load relative and store relative instructions work, you're storing relative to what's in this register. It uses this register as an address, a pointer, if you will.